Imagine a day when our sun turns not into a fiery monster, but into a gentle thief, slowly stealing the world's heat, its climate, its balance, without you even realizing. The end doesn't roar, it whispers. Above our blue planet, the sun looks unchanged, a steady glow in the vacuum. Yet, beyond our eyes, its pulse is shifting, not with a blaze, but with a subtle rhythm, its warmth slipping through our fingertips. Since the late 1970s, satellites have monitored the sun's total energy output, its total solar irradiance, and found it has fluctuated by less than a mere 0.1% over the 11-year solar cycle, with no sustained upward trend overall NASA Science Wikipedia. However, recent reconstructions suggest a marginal, long-term decline may be occurring. Models analyzing magnetic activity and facular light show a slight downward trend since the mid-1990s archive. Compounding this is Earth's own atmospheric veil. Between the 1950s and 1980s, many regions witnessed a sharp, global dimming, a 4 to 5% per decade drop in sunlight reaching the surface, attributable to aerosol pollution. Wikipedia phys.org. This trend eased in the 2000s as air quality improved, allowing sunlight to rebound in some parts. phys.org. On a broader scale, researchers warn of a modern grand solar minimum occurring approximately between 2020 and 2053, part of a 400-year solar activity cycle, potentially cooling Earth by up to 1.0 to 1.5 degrees Celsius. Wikipedia. Yet, human-driven warming remains the dominant force. Even a solar lull cannot fully counteract it. Wikipedia +1. This chapter unfolds with cinematic scope. Start with a sweeping cosmic shot. Earth bathed in an ancient, steady sunlight. Then slowly zoom into a high-tech satellite orbiting Earth, measuring the sun's rays, revealing tiny declines in intensity. Transition to industrial scenes smothered in haze, where dimmed light falls through polluted skies, slowly restored as cleaner policies emerge. High above, satellites whisper truths. The sun's heartbeat is steady, yet its warmth shows the slightest fracture, a near imperceptible ebb. On Earth, factories once suffocated the sky. Roofs missed the sun's kiss in dusty gray. Yet where clarity returned, light returned too. Not in roaring surges, but in quiet gratitude. The sun isn't exploding, it's subtly withdrawing. And though our planet remains radiant, the clues emerge in the hush between heartbeats. From here, you can expand by weaving in observational data on TSY from instrument composites and proxy-based reconstructions. The role of aerosol pollution in dimming trends globally, especially in industrial centers like China. The uncertain yet scientifically plausible onset of a grand solar minimum with its potential but limited cooling effect. When the sun changes, it does not choose its victims. From the equator's restless seas to the Arctic's fragile ice, the tremors of a dimming star ripple everywhere, often in ways we don't connect. A farmer in Punjab stands on dry, cracked soil. His calendar says the monsoon should be here, but the sky refuses. Scientists have begun noticing subtle shifts. A weakened South Asian monsoon during prolonged low solar activity linked to cooler land-sea temperature contrasts. The effect is slight, fractions of a degree, but enough to delay rains and cut yields. Thousands of kilometers away in the tropical Pacific, El Niño and La Niña events, giant swings in ocean temperature, are showing signs of altered timing. Studies in the past 5 years suggest solar cycles can nudge the Pacific's winds, either reinforcing or disrupting these patterns. The result? Unexpected floods in Peru or drought in Indonesia, not easily explained by greenhouse gases alone. Move north, and the jet stream, the high-altitude river of air-steering weather, begins to wobble. In Europe and North America, unusual cold snaps appear amid warming trends. Research from 2023 using high-resolution climate models found that low solar output may weaken the polar vortex, letting Arctic air spill south more often. In 2021, Texas froze. In 2023, Spain saw snow in April. Rare, but not impossible. At sea level, corals in the Maldives and Australia's Great Barrier Reef face a double-edged threat. Slightly reduced sunlight changes their energy balance, while warmer oceans from human-caused climate change stress them further. Some species lose their symbiotic algae not just from heat, but from altered light quality, a connection only recent reef studies have begun to explore. And yet, the most haunting impacts are invisible: shifts in phytoplankton growth. These microscopic plants feed the marine food chain and produce much of our oxygen. Variations in sunlight intensity, even by 0.1%, ripple through ocean productivity. Satellite data from NASA's MODIS and VIIRS instruments show that regions like the North Atlantic bloom weeks earlier or later than before, disrupting fish migrations and local economies. The sun's whisper is felt in every drop of rain and every wandering wind. In Punjab, the monsoon hesitates. In the Pacific Ocean, giants turn in their sleep. Europe's skies swap spring for winter without warning. Beneath the waves, corals dim, and tiny plankton drift out of sync with the seasons. These aren't the fireworks of apocalypse. These are the quiet missteps in Earth's ancient dance, choreographed by a star that no longer keeps perfect time. The sun, our constant, our compass, yet when we finally learned to touch it with instruments, we discovered it was not as constant as we believed. In laboratories and observatories around the globe, scientists are piecing together the sun's hidden rhythms. Its 11-year solar cycle, rising and falling in a heartbeat of magnetic storms, is just the beginning. Buried deeper are grand cycles spanning centuries, even millennia, that remain only partially understood. The Parker Solar Probe, now skimming closer to the sun than any craft before it, has begun mapping the chaotic dance of plasma and magnetism near its surface. In 2024, it detected fine-scale magnetic switchbacks, kinks in the solar wind, hinting that the sun's magnetic engine may shift in ways that alter total energy output over decades. The European Solar Orbiter complements this view, capturing the highest resolution images ever of solar poles, where the seeds of future solar cycles form. These missions feed into complex climate solar models. Some researchers warn that, based on reconstructed sunspot records and cosmogenic isotopes in ice cores, we may be drifting toward a modern grand minimum, a prolonged period of weak solar activity similar to the Maunder minimum of the 17th century, when Europe endured unusually cold winters. Others argue these patterns are natural oscillations, unlikely to trigger severe cooling in our already warming world. And then there's the wild card, the sun's influence on cosmic ray flux. During low activity, Earth's magnetic shield lets more cosmic rays in, potentially increasing cloud formation. It's a controversial hypothesis, but if true, it could explain certain abrupt climate anomalies in history. The CLOUD experiment at CERN continues to test this, recreating micro-atmospheric conditions to see if cosmic rays can seed clouds. Results so far suggest the link is weaker than some claimed, but it's not ruled out. Even with petabytes of data, gaps remain. The sun's internal structure, the tachocline, where magnetic fields are generated, is hidden from direct observation. Heliosismology, the science of studying solar quakes, offers clues but no definitive map. Without fully understanding this layer, predictions about future solar behavior remain part science, part educated guess. We stare into the sun and think we know it. Yet each probe, each instrument, returns with riddles. A magnetic twist here, a faint dimming there. Patterns half remembered in ice and stone. Is this simply the sun's natural breath? or the prelude to a deeper change? In the silence between answers, speculation grows, bridging the gap between what we see and what we fear. The sun may fade, but in that fading, something else begins to shine. Around the world, a quiet revolution stirs, not the panic of disaster, but the careful, deliberate hum of preparation. Scientists, farmers, engineers, and everyday citizens are learning to live with a sun that might one day give a little less. In glass towers rising over crowded cities, vertical farms glow with artificial suns. LED arrays tuned to the exact wavelengths crops need, regardless of what the real star provides. In remote fields, solar concentrators redirect and amplify sunlight onto greenhouses, stretching the growing season through cooler months. Geneticists work in silent labs, editing the DNA of staple crops to thrive in lower light. Wheat that once withered in long winters now ripens under cloudy skies. Rice varieties that once demanded hot, bright summers learn to live with gentler warmth. The work is urgent, but its urgency is quiet. A scientist's urgency, measured in years, not seconds. Policymakers, often slow to act, are starting to listen. Climate adaptation plans now include solar output contingency models, forecasts not just for heat waves and floods, but for the possibility of cooler, dimmer decades. Energy grids are redesigned to store more power for longer nights. Heating systems become as critical in the tropics as they are in the poles. Communities adapt in their own way. In a fishing village in the Maldives, locals shift their harvest calendar following the altered plankton blooms. In Northern Europe, urban planners plant darker-leaved trees to absorb more sunlight and warm streets in the chill. Across Asia, rooftops transform into light gardens, catching and focusing sunlight into shared courtyards. And yet, perhaps the most profound change is in our perception. For thousands of years, humans worshipped the sun, a god, a giver, a constant. Then we saw it as a machine, predictable, mechanical, unyielding. Now, we are learning to see it again as alive. Not in the way we are alive, but as a dynamic force with moods and rhythms we must respect. The end will not come in fire. It will come in shadows. Gentle at first, then deepening. But in that shadow we will light our own lamps. From the smallest seed adapted to weaker rays, to the cities reimagined for colder skies, humanity will meet the sun's whisper with a quiet roar of ingenuity. And when our star dims, we will not fade with it. We will endure. We will adapt. We will shine.